The SD Ruby podcast is brought to you by New Relic.
Hi everybody, I'm Jonathan. First I'd like to apologize, I lost my voice earlier this morning, so I'm going to try and muscle through this. If you can't hear me, speak up. So the talk today is about switching from Mongo to Postgres. It's something that if you spend any time on Hacker News, you'll know that there's just tons of like religious wars and flame wars about what you should be using as your data store. And I'm going to avoid most of those and just talk about the actual mechanics of deciding if you need to do a switch and a migration, and then how you actually do that migration. Because there's not just like an export tool, or at least I didn't find one. If there is, then I feel kind of stupid because we spend a lot of time doing this. So just to give you a little context, the project that this was for a company called AppStack. AppStack is a startup based in Temecula that has just great investors, like Google Ventures behind them. They're super fast growing, they're about a year old, and within that year they've gone from not existing to being the largest reseller of Google mobile ads in the country. So there's significant money going on here, and so a transition like this, like a core infrastructure change like this, needs to be solid and it can't like disrupt the business. So the actual application is letting local businesses build mobile websites for customer acquisition, and then AppStack would go out and buy advertising on Google to drive people into those businesses. So what was the motivation behind the switch? So there were three primary things going on. The first was the company started out where a document store made a lot of sense. And so Mongo actually made a ton of sense because we were just generating apps for people. But once the company started doing advertising, we started having things like accounts that were related to billing and related to users, with ads, with keyword groups, and all these things. And as you start talking about the app like that, you start realizing that, hey, this is exactly what relational databases were meant to kind of support, right? And so because the business had pivoted into this area, it just didn't make sense to try and do all this functionality within Mongo. The second thing was developer productivity and developer happiness was pretty low for us because we had to do a bunch of things like all these set operations to do like a super simple join. We're like, dude, this feels really lame, and it wasn't that fun. And then finally, the business was run really quantitatively. So it's a call center based business, so you had a bunch of salespeople, you had a bunch of businesses that you're selling into, like local businesses. And so our COO was running the business based on numbers. And those numbers were all based on his analytics tools, which all expected a SQL backend. And so what we were doing is we were taking all of our Mongo data, and every night we were exporting it to a MySQL database. And so we were doing all this work that essentially was putting a schema onto our schemaless data store. And so that was a big pain, right? And not only was it a big pain, but from a business perspective, they didn't have real-time data about the business. It was nightly, which wasn't necessarily good enough. So those were the three primary reasons that we switched. I probably don't know enough about the two platforms to like make some sort of like overgeneralization. So you can go to Hacker News for those. But that's why we switched. So the four things that you have to do a switch like this is first you have to actually create a schema, right? So you have to look through all of your data and you have to say, hey, this is just a big pile of data, let's create a schema from it. Because Mongo lets you just put anything in, right? So that's the first step. The second step is you actually have to get your data into that format, into Postgres. The third step is you have to make your code work with Postgres. And then finally you have to turn it on and hope for the best. So as far as creating a schema, the first thing that we tried was there's tools that will just dump the data out and try and like guess what each piece of data, like what the format of that should be. So it'll be like, you know what, this, 90% of the time in your system it looks like this is an int, so we're going to call this an int, right? Which, when you look at what got spit out, you're like, dude, this is going to take a lot of work to actually figure out what we meant by all these things, because we were just throwing data into the system. And so you have things like refactors that would come along and just leave old data in there, right? Because we weren't like constrained by a schema. So that was the first thing, but after looking at what these utilities spit out, I decided that that was really not the way to go. Luckily, we were using MongoDB, so that's the equivalent of active record in this case, and it actually uses field definitions to try and enforce some schema on top of Mongo. And so what we were able to do is write just a really quick utility, which is on GitHub. There'll be a link at the end, but it's on GitHub. A really quick utility that just spit out a migration, like the text of a migration, by just using a little Ruby metaprogram to look at all of our Mongo models. And so this part here actually probably took less than a day. It's maybe 50 lines of code. You can check that out later. But that was actually fairly easy, which is cool. Two things on this before I go on. The first is we resisted the urge to do refactors at this point. Like when everything is like just getting thrown around and you're breaking everything, like this is a really bad time, we thought, to do refactors. Even though there was always like this desire to clean things up as we were going, the complexity of just doing it right without refactors made it, to us it seemed like it was just too much to throw in a bunch of cleanup on top of it. The other thing that we did is we created the schema was anytime we had foreign keys, or any key actually, we would create an old field for the Mongo keys, as well as a new field for where the Postgres key would go. So keep that in mind as we go to this section, which is the second step, which is massaging the data to get it into the schema. And this ended up being the hard part. Because you have all this stuff, right? You have to actually make it fit into the schema that we just created. So we kind of took the same approach here, where we use MongoDB and we use some metaprogramming to just loop through all of our models and output everything in there to a single insert statement for every row. And then we ended up with like a 200 megabyte SQL file that you could just load into Postgres. So that's like the approach that we took to actually get it to work. It was a lot of work. And most of the work, I would say, was probably in figuring out how relationships worked, because you could do things in Mongo like you can have embedded collections, right? But once that goes into Postgres, all of those rows are just in one big table, right? And so you have to flatten it out of like the hashes that we were storing it in within Mongo into just one big table. So you had to do that with polymorphic relationships, has and belongs to many. Like there was just a lot of little details like that that we had to get right. So this was where we spent most of the time, or where I spent most of the time. Once you have everything in insert statements, you have to actually, you have this graph of objects, right, coming from Mongo, and you have to keep that same graph with all the Postgres objects. And that was difficult as well, because you had to figure out what foreign keys mapped to what. So I'm going to try and explain that. So we would have like a Mongo account ID, which was the BSON ID, which is what they're using as their key. And we don't know what the Postgres ID is going to be at this point, right? Because we haven't created it yet. And so this is for every foreign key in the system. So what we did was, in the insert statements, I just put a placeholder value. So it's the BSON ID with the text placeholder appended. And then once you actually saw this object get created with an insert statement, we would know what the ID was. So we could actually create a mapping between those. So this first hash here is like a mapping that says, hey, this BSON ID maps to this. And at that point, yeah.
I was wondering why you couldn't just stick with the IDs you had from Mongo.
Because, well, so first we didn't want to. We actually wanted to just use like a Postgres sequence. Because we were actually, for usability, we were actually using sequences in some of our models anyway. because we didn't want to like give customers like, hey, this is your user ID, right? So we were already doing some of that, and we wanted to just standardize. So at this stage, once you have this mapping, you can take this big just dump file, and you can do a gsub across all of your IDs and replace all of the placeholders with the new ID. But if you've ever tried to do 300,000 gsubs on like a 200 megabyte file, you know that it's really, really a bad idea. So I think I killed the process after maybe 4 hours. And I was like, this is not going to work. Because one of my goals was I want this like export to be really quick, because I'm going to make a lot of mistakes. As I'm like doing it, I want to be able to like iterate really quickly as I'm making this exporter work. So what we ended up doing was creating an index. So instead of just dumping everything into one big file, we just had a big array of every insert in the system. And our data set was only about 300,000 rows across every table in the system, so it was actually pretty small. So we had this 300,000 element array, and then every time I had a placeholder, I would just index into wherever that array was, right? So this object was given reference in the insert statement 358, right? So then you could just gsub on that specific one. And so it went from like a 4-hour process to do this graph change to like a 4 or 5 second one. So that was actually probably the funnest part of the whole project, because it was actually like it wasn't like just tedious changing code, like you actually had to figure out something clever about how to do this quickly. So that was pretty fun. So the tedious part was actually just the code conversion, because you have, I mean, almost every line in the app, it felt like, had some sort of dependency on our data store, right? I mean, it makes sense, but when you're actually going through and changing all that, it gets to be pretty time consuming. So I didn't know a quick way to do this except just brute force, find and replace, just find all Mongoloid syntax and swap it out for active record, joins, and things like that. And so we did that. And every time I would do like a merge, I'd have to go back through and do this. And then the other thing was, replacing the actual syntax of how we did relationships, right? So instead of embeds many, you have has many, right? So you just have to go through and just all of those little details. And one of the problems was that when we started the project, we actually didn't have any test coverage, which, as a developer working on a big refactor like this is pretty scary. So by the end of the project, we'd written a lot of tests, but still, it felt like, you didn't know what was going to happen. So you had to do a lot of just manual, walking through the app and making sure everything worked. So the code conversion was the third step. The fourth one was actually turning on live. And so Kevin Thompson, our director of engineering, and I just stayed up really, really late one night, and the actual process of making it go live is pretty easy. You take the site down, you make sure all of your delayed jobs and everything are cleared out. You do the export and you deploy, and then everything is great, right? And it actually was almost that simple. Like once we actually got to that point, it was pretty simple. And the next morning we had some airbreak errors, but it wasn't too bad. So the three problems that we ran into that were significant, that weren't just like syntax things that I missed or something like that. The first is, does anyone see what's wrong with this? Because I looked at this maybe 100 times and I never saw the bug in it. This will actually clean up any apostrophes by just removing them. So that was bad news. The next day we got this email from one of our customer support people that was like, we haven't seen any apostrophes in our app. But the great thing is, you can just write a little updater to put them back in. A little great task. The second one was actually time zone. So every project that I've been a part of, I think, has had a time zone bug that was really painful. And this one, I was like, this is not going to have a time zone problem, right? Like, I'm just going to make sure that it's right, and it still did. But I think most of our times were off by a couple of hours or something. But same thing, like just a really quick break task to update those things, and no data loss or anything. The harder thing was that whole graph replacement scheme that I was talking about. That depends on all keys across the whole system being unique, and that actually turns out that was not true for a very brief amount of time before we had some indexes in Mongo. So like a very small sliver of data had duplicate BSON IDs for some collections, some sub-collections. So what that meant was when you did this whole replacement thing, you were actually hooking up some data to the wrong object. So we had, taxi drivers that also were advertising for tattoos and stuff like that. It was a small enough subset of data that we actually didn't know what was wrong for like a week. We actually didn't know something was wrong. And once we figured that out, we were just able to change the foreign keys and fix it. But that's really good to know that sometimes Mongo reuses BSON IDs, even though I don't understand why they would, but they did. So that was my bad for not catching that. Okay, so what were the results? So the first, I think that was the most significant, was that we had a test suite by the end. I think that, something to force that transition was really, really good. Because refactors going forward, hopefully are much, much easier. I would say that developer happiness increased. I don't know what you guys think since you still work on the product, but I think that that being able to use active record and to be able to do things like joins really simply, the way it was designed, was a beautiful thing. And then finally, the business reason that we made the switch, I think was, that was a great result too, that our ops people got like a real-time view into the data. Like that's a big deal. And I think that's probably the only thing in the end that makes something like this worthwhile, is if it's really helping the business, because it's so much work and it just feels like if you don't have a really good business reason to do it, then stay away from refactors this big. So what did I learn from this? So when there's a business reason to do something like this, do it early when you only have 300,000 rows in your database, right? Because it just gets harder, and the complexity of the app was never going to get easier, right? So the earlier we did it, the better. Testing is your friend. I get tired of saying this, but a great test suite just makes it so much easier to do these sorts of refactors. The other thing was, when you're touching this much code, it would have been helpful for me to just do merges from master much, much more often, so that the day before I turned it on live, I didn't have to go back through and do a bunch of switching out Mongoloid syntax on new features that have just been built. So I wish that I would have done more and more merging. And then the final thing is figure out how to test your data. I'm sure there's like really good ways to do this. I just didn't know what they were. And so that's probably an inexperience. My inexperience in doing big data conversion projects like this. I didn't know how to test the validity of what we were getting out of Mongo was mapping to Postgres. And so that would have actually found most of our major bugs that we had to find once it was in production. So that's all I have. GitHub has both great tasks. They're actually very little code, and you'll have to modify it. Like if you go through this process, you'll have to modify it for your specific data set and your specific account. But the code is there, and it's interesting to look through. So are there any questions? Yeah.
You said the COO had based his numbers on analytic tools that were using SQL type data.
Yes.
Why did you have Mongo in the first place then?
I'm
just curious
what
the decision.
Well, so the business changed over the course of the year, right? So initially we were just selling mobile apps, right? Which I think the analytics on that are probably much simpler. Good question.
Did you do any kind of data validation before going live?
Nothing automated.
Just manual?
Yeah.
And you mentioned some tools you looked at before going down the wrong road.
Yeah.
I don't remember the name. Why did you not decide to go with it?
So the question is, why do we not use some of the tools that we tried? So, like, are you talking about the ones that infer schema from MongoDB?
Sure.
So it would infer schema even from data that we had just left in the system after a refactor or something that, right, because we weren't doing like migrations as you think of it in Postgres or in Active Record. We were leaving old data in there, and there was just a lot of things that it was guessing about, like this is something that they need, or this is a image, or even though it may not be. Those tools were looking at what things were on average to try and infer schema. And it ends up that just using our code to kind of dictate the schema wasn't much simpler thing to do.
You guys looked at using both, like having portion of the data in Mongo and having portion of the data in Postgres, like how that would work. I mean, I've read about that stuff, so I'm just curious how that works in real life.
Yeah, so the question is, did we look at having both systems coexist for different parts of the data? And we did. We actually were going to do that. We were going to keep the applications in Mongo because that's what initially we made that decision for, and then all of the advertising and user accounts and everything in Postgres. Once I dug into actually doing that, it just felt like there's a lot of infrastructure to keep both going. And so we just made the plunge, took the plunge.
It's too complicated to maintain both ends.
That's what it felt like, yeah.
Yeah, thanks.
Yeah.
If you had not used Mongo, would you just have been screwed, or how would you approach that differently?
I have no idea. Yeah, so the question is, if you not used Mongoloid, what would we have done? I don't know.
Make your own keys.
Well, so the keys were dependent on Mongo generating JSON IDs. Mongoloid wasn't doing that part. Is that?
Yeah, I just mentioned, just asking because you said it was used.
Oh yeah.
People were out there using what they.
Yeah, I don't know what they do. I don't know because I mean a lot of people are making a switch. I don't know how they're doing it. I would read these blogs about people that they'd be like, oh, I tried Mongo and then I switched back to Postgres, and it was like a one sentence thing, and I'm like, dude, how did you do that? Like, it's not just a one sentence thing. Like, it's a lot of work. I think maybe if you're still like in development, it's not that big of a deal, right? Because you don't have production data, you don't have.
Right. Maybe your data set's smaller.
Yeah. Or you're not we have significant money flowing through the system, so like that was like I don't want to screw it up. But if you're a smaller site, or it doesn't matter that much. Yeah.
Having worked with both now, would you reflect on when you would advise someone to use Mongo and not?
So the question is, having worked with both, like when would I advise people to use one or the other? I'm so much more comfortable with SQL that it's hard for me to give an unbiased answer. Like I would just go with it every time at this point.
You weren't one of the people that chose Mongo and developed it.
No.
And you guys?
Not only me. I'm new there, I was not a part of that decision.
Yeah, it was originally nice. It was because we were storing a lot of denormalized application data. Our original product was a comprehension system for provisioned iOS native apps. So we were planning on having a large feature set for a number of different mobile applications all stored in a single database. So that was the purpose, was that we were going to have no common schema across all of our applications. It made the most sense in that regard. Now we have a common set of features across all mobile applications. So we do have a schema. So regardless of whether or not we would have kept it in MongoDB or a relational database, it would have had a defined structure. So having that defined structure in place, it made the most sense to switch to a relational database.
I mean, in general, I prefer the familiar, and that's, maybe I'm just not interested enough, but.
I've definitely used both on projects before, like simultaneously.
Yeah.
And sometimes schemaless is just the right tool for the job.
Yeah. Any other questions? Is anyone thinking about going to the switch?
I want to know how you got those apostrophes back.
Yeah, what did you do? What happened?
I'm not sure. No, so those sorts of changes are very easy, because first there's not, like the data doesn't diverge that much, and especially in this particular data set it wasn't
So would you
diverging that
push
much.
that back to the?
So you had the original,
Yeah, because you still have your MongoDB, so you can actually see which,
Oh, okay.
you can actually look at, hey, you know, this record was imported from Mongo, this was the Mongo ID, because we kept that, remember? And that was why, so that we could go back and change
Okay.
that. So you can just write, it's actually really simple, to just write an update. Any other questions?